Okay, guys, we're going to expand a little more on our multiplying polynomials that we've been dealing with. Now, you're going to notice on this screen right now, this method 1 and method 2 are exactly like we talked about in the last couple sections. But we're going to expand what we're multiplying by. It's going to become more than just one thing times a few others. So there is a method called FOIL that I'm going to talk about and show you on this one. And when we get done, whether you use FOIL or whether you decide you want to use this box method, it's up to you. So you do kind of need to know that if they talk about using FOIL, that using the box method is the same thing. So FOIL is something that is an abbreviation. It's like if you were ever younger learning all of the Great Lakes, you might have learned the word homes. In fact, that's probably the only reason I remember all 5 of them, because I can go down in order. So Huron, Ontario, Michigan, Erie, Superior. So they help you remember what you're supposed to, be able to recite back or know of the Great Lakes. Same thing with FOIL. FOIL is based on using these letters to kind of help us. So FOIL talks about multiplying the first 2 terms together. O talks about multiplying the outside terms. I is the inside terms. And L is the last 2 terms. So I'm going to go through an example of this with you. And again, once we do the first one, you can decide which of the methods you want to use, this one or this one. I will be really honest, I like the box method for everything, because it doesn't matter if I have one thing times 2 things or 2 things times 2 things or however many there are, the box method will always work. FOIL only works when you have maybe something like this times something like this. It has to have 2 items in the first one and 2 items in the second one. So again, I'm going to go through and show you an example of this using FOIL, and then it's up to you which way you want to do this. First of all, I did all 4 steps here, and this is going to be to multiply 3x plus 4 times 2x minus 5. So these are basically step 1, 2, 3, and step 4 to being able to solve these. So what I'm going to do is I'm actually going to go through and mark on here the ones that we're going to multiply together. So when it talks about the first in this one, then we're talking about multiplying, I'm trying to get my highlighter to work here. I guess it doesn't want to. Multiplying this number times this one, because they are the first numbers in both. So 3x times 2x is going to be 6x squared. Okay, now I'm going to go to my next one. And they want me this time to do the outer part of this. So to do the outer, I'd have to do the ones that are the furthest out from each other, kind of the first of the first one, the last of the last one. So 3x times negative 5 is negative 15x. Okay, now we're going to go to inner. So if I look at inner has to do with the 2 terms that are the closest together inside. So 4 and 2x. So if I have positive 4 times positive 2x, it's going to be 8x. Okay, now I'm going to go to last. So last is when you do the last terms in both parentheses. So that would be those 2. So positive 4 times negative 5 is going to be negative 20. Now we're going to put these together. So 6x squared minus 15x plus 8x minus 20. Now the only one that has anything alike would be this, because they both have x terms. So negative 15x plus 8x is going to be negative 7x. I'm going to bring down the minus 20 and the 6x squared that's at the beginning. Now, there are lots and lots of examples on FOIL. There's a whole bunch of them on my YouTube page already. But I do want to show you the box method for a couple of these so you can have definitely ones that you can work with to see if it's going to help or not. Because that's ultimately what we want. We want to know when you go to do first, you do outer, you do inner, or you do last, that you're able to do it, whether you use the box method or not. Okay, so I'm going to give you a couple examples that we're going to work through here. So first of all, on this first parenthesis, on example 1, it's x plus 7 and then x minus 3. Now, I assume in front of both of these spots right here, I would have a 1. So it's really 1x plus 7 times 1x minus 3. Now, if I was going to set this up, I'm going to do the box method, but I want you to notice how it's going to look this time. I'm going to take 1x plus 7, and I'm going to split those two terms going down the side of the box. And then I'm going to do 1x minus 3 across the top. Now, we're going to do the same kind of thing we did before. We're just going to multiply them together. So 1x times 1x is 1x squared. 1x times negative 3 is negative 3x. Positive 7 times 1x would be positive 7x. Positive 7 and negative 3 is going to be negative 21. Okay, now if you take a look at what I have here, those two are the only like terms. Typically, if it's in standard form to begin with, then typically you're going to have like terms that might be diagonal. They might be moved around in the square. If they are, or in your rectangle, just go find them. But if I do positive 7x minus 3x, it's going to be positive 4x. And then the 1x squared goes in front, and the minus 21 goes on the end. Now, the only thing they might do is drop that 1 in front of the x squared because they'll assume it's there whether they write it or not. Okay, let's go to another one. We'll kind of do a few examples so you'll have a few things to use and look at. Okay, I'm going to go set these up. Everything has a number in front of it except the x minus 2, so I'm going to do 1x minus 2. And then I'm going to go ahead and start setting it up. So 2x plus 9 1x minus 2. Okay, now if I'm going to look, 1x times 2x is 2x squared. 2x times negative 2 is negative 4x. 1x times positive 9 is positive 9x. And negative 2 times positive 9 is negative 18. Now, just like we talked about in the last one, we can see a couple terms that are alike. So positive 9x plus negative 4x is positive 5x. I'm going to bring down the minus 18 afterwards and the 2x squared in front. Okay, now remember, these do have to be in standard form. So that means the highest exponent should be there, and then kind of working your way down. Okay, take a look at these, and we'll do a few more of them later in the week.